Hello, this is Adam. Today I'm going to teach you how to do question number 4 of a 2012 FRQ question for Calc BC. The first question asks for you to write an equation for the line tangent to the graph of f at x equals 1, and then to use this line to approximate f of 1.4. So the first thing that you need to do to get the first point of this problem's worth 2 points, is to find the tangent line f of x at x equals 1. So for any equation where you want to find the tangent line at a point, you could use this formula right here if you're given the y value and the x value for that point. You say y minus y1, where y1 is equal to the value of y at that point, equals derivative of x1, where x1 is the point, the x value of that point, and f of x1 is equal to the derivative at that point, x minus x1. So in our case, we know that the derivative of f of 1 is equal to 8, so this is equal to 8. F of 1 is equal to 15, so x equals 1 and y equals 15. So you plug these points in and you get y equals 8, x minus 1 plus 15. Next part of this question asks you to find the approximation. So simply just plug in the x value that they want you to find the approximation for your already established equation. So plug in 1.4 for x and solve for that, and it simplifies to 18.2, which is an approximation. Part B asks for you to find a midpoint Riemann sum between two subintervals of equal length and values from the table to approximate the integral from 1 to 1.4, the derivative of f of x dx. So they want you to use this approximation for the integral of this right here, pretty much, to estimate the value of f of 1.4. That's the second part of the problem. And then you need to show your work, which you should always do for the FRQ, because that's how you get all the points. So the first thing that you need to do to find the midpoint sum, Riemann sum, between these 2 points is to find out the midpoints. So since there's two subintervals of equal length and this is a midpoint sum, we want to use the values of f of 1.1 and f of 1.3. That's because they are the middle values of this table. Now that you have these values, you need to know the distance between these points. 1.2 minus 1 is 0.2, and 1.4 minus 1.2 is 0.2. So they both have widths of 0.2, and the value of f of 1.1 is 10, and the value of f of 1.3 is 13. So you can simplify this. These simplifies to 2. This simplifies to 13 over 5, which is equal to 2.6. Add them together, and you get 4.6. And that gets you 1 point. That is part 1 of this question. For the other 2 points, you need to use this to approximate f of 1.4. So by the fundamental theorem of calculus, this approximates the difference between f of 1 and f of 1.4. So since we know the difference between these two, and we're given the value of f of 1, which is 15, we could add f of 1 to this difference to get the approximate value of f of 1.4. So you do that, you add 15 to 4.6, and you get 19.6. Showing your work for this part gets you 1 point, and your answer gets you 1 point, for a total of 3 points. Alright, part C asks for you to use a Euler's method, starting at x equals 1, with 2 steps of equal size to approximate f of 1.4. And they want you to show your work. As always, always show your work for the FRQs. So, for the first thing that we need to do in order to do the Euler's method is understand, if we only have 2 steps, how to make them perfectly equal. From stepwise from 1 to 1.4, 1 plus 0.2 times 2 equals 1.4. So the step size is 0.2. To do Euler's is you have the initial y value plus the step size times the derivative at that value to find the next value. And then you put that value in and you do it again. So for our case, you want to approximate f of 1.2 first using Euler's theorem. We would have f of 1, which we know is equal to 15, times the step size times the derivative at that point, which is 8. And this simplifies to 16.6. From f of 1.4, we're stepping from 1.2 to 1.4. So we want to use 1.2's value of 16.6 plus the step size times derivative at 1.2, which is 16.6 plus 0.02 times 12, which is 19. So the answer is 19. To get all the points for this problem, you must show Euler's method and you must get the correct answer. Here's part D. Part D asks, write the second degree Taylor polynomial for f about x equals 1. Use the Taylor polynomial to approximate f of 1.4. So if you don't remember what a Taylor polynomial is, it's basically an approximation of an equation at a point, similar to normal tangent line at a point approximations, but it takes derivatives into account. So when you take the derivative, it will be the derivative of the actual value. So you want to take a second degree Taylor polynomial, which means it goes up to the second derivative. So you know what f of 1 is equal to, it's 15. You know the derivative of f of 1, which is 8. And they give you the second derivative of f of 1, which is 20. So you set that up into a Taylor polynomial equation. The first degree is 15. The second degree is 8 times x minus 1, since it's about x equals 1. That way, when you plug in 1, this is equal to 0, and you just get the actual value. When you take the derivative, this becomes 1, this becomes 0, and you just get 8. And for the last one, you know that the second derivative is 20, but because there's a second exponent here, this is 10. So that way, when you take the derivative twice, this becomes 0, this becomes 0, this becomes 10 times 2 times 1, which is 20. So there's your Taylor polynomial approximation. That's the first point of the 2 points for this equation. The second point is for finding the approximation at x equals 1.4. To do this, simply plug in 1.4 for x. So you get 15 plus 8 times, in parentheses, 1.4 minus 1. And the same kind of thing with 10 right here. So you simplify that again, and you get 19.8, which is the answer. So that's it for all of the problem. If you want some more practice, there's links in the description. And thanks for watching.